Hello, this is Tyler Beamer, math instructor, Haywood Community College. This is an instructional math video for module or DMA 030. This video is in regards to module 3 section 7, which is capacity. So we're looking at both US standard units and metric units. So once again, I want to draw your attention to the conversion sheet that's on Moodle you should be using. So here are the US standard units for capacity that we're going to be using. So we're looking at fluid ounces, which is not to be confused with ounces for weight. So fluid ounces, capacity. Cups, pints, quarts, gallons. So if you've ever done any canning or cooking, you're probably familiar with those measurements. So we're looking at essentially volume, in most cases liquid volume here for capacity. And then of course in the metric system we're looking at the last row here, capacity. The base units is liters. So you guys are probably familiar with liters if you ever have bought soda, 2 liter of soda, or even a liter of soda. Once again, liquid measurement, volume. So liters, deciliters, centiliters, milliliters. That's the smallest, milliliters. And then we got deciliters, hectoliters, and kiloliters. So largest to smallest, like it has been. So we're looking at that third row on the metric system. So I want to go through some examples that are similar to your homework problems, get you started here, still using the same idea of unit fractions to do our conversions here. So all of that's going to remain the same. We're just going to be using a different set of conversions. So alright, so the first one says 20 cups to gallons. Okay, so this is actually going to be red. This is actually going to be a multi-part conversion. So 20 cups, and we want to go all the way to gallons. Okay, so we want to first convert cups to pints, since that would be the next one up on our conversion list, so that we know there are 2 cups in 1 pint. So we're moving up our conversion sheet for capacity here, trying to make it all the way up to gallons. So cups are going to cancel, and that's going to leave us with pints. And then we want to go from pints to quarts. So we know that there are 2 pints in a quart. So I'm going to put pints here. And quarts up top, right? Keep in mind we want to have the units that we want to cancel top and bottom, like we've been doing. So that puts it in quarts, and then we want to go from quarts to gallons. So we know there are 4 quarts in 1 gallon. So quarts are going to cancel, and then our unit should be gallons, and that's what we want. So that's the first step, is to get our units right, write our unit fractions, and since this is a multi-step conversion, we could do it all in one fell swoop with the unit fraction. So now just multiply those fractions together. So on the top I'm going to get 20 times 1 times 1 times 1, and on the bottom 1 times 2 times 2 times 4. So that's going to be 4 times 4, so 16. So 20 over 16, and of course that's not going to divide evenly, so we get 1.25, which will be 1 1/4 gallons. Okay, so like I said, the unit fraction remains consistent, the process remains consistent. It's just using your new conversions for capacity. So here's another example, 80 fluid ounces. So if it's fluid, it's going to have the FL in front of it. Make sure that you don't get that confused with weight ounces. Okay. So we want to go from fluid ounces to pints, so we got to go from fluid ounces to cups, and then from cups to pints. So we know there are 8 fluid ounces in 1 cup. So I'm going to put fluid ounces on the bottom, that way fluid ounces cancels and I'm left with cups. And then we want to go cups to pints, and we know there are 2 cups and 1 pint. So 2 cups, 1 pint, and then that should cancel cups and leave us an answer in pints. Okay, so get the units right using the unit fractions, and then do your multiplication of fractions. So we get 80 over 16, which is going to be 5. So 5 pints. Okay. Next problem is another one of those long division problems where you're taking 39 pints and you're trying to figure out how many whole gallons there are, how many whole quarts there are, and how many whole pints there are. So it's almost like you took a large pitcher and it was filled with 39 pints, and then you had some empty milk gallons, and you were filling up as many of the empty milk gallons as you possibly can. Full gallons we'll set aside, and then of course the last one you're probably not going to be able to fill all the way up. So we take that last one that's not filled all the way up. You got some empty quart jars on the table. Fill up as many of those quart jars as you possibly can till they're full, and you'll inevitably have one quart jar that doesn't get filled all the way up. Take that one, put out some empty pint jars on the table, fill up as many empty pint jars as you can until you have full containers for gallons, quarts, and pints. So that's what this problem's asking. Okay. So we can do some long division here, right? We want to figure out how many pints there are in a gallon, right? So how many pints in a gallon? Okay, so we know that there are 4 quarts in 1 gallon. Okay, so we're essentially going from gallons to quarts, right? So 1 gallon and we know there are 4 quarts in a gallon. So 4 quarts in 1 gallon. So gallons are going to cancel. And then we want to go to pints. Right, we know that there are 2 pints in a quart. So that should put us in pints, right? Gallons cancels, quart cancels, I'm left with pints. So now multiply. So 4 times 2 gives me 8. So there should be 8 pints in a gallon. So that's really the first step. Okay. So how many pints in a gallon? The answer to that is 8. Right? So why do we need that? Because that's going to give us our divisor. That's what we're going to divide by. Right? We're going to divide 39 by 8. Right? If however many times 8 goes into 39 completely, right? Whole number of times, that'll be the number of gallons that we have. Okay. So if I divide that out, right? 8's going to go into 39 at most 4 times. Okay, so this is whole gallons. So I answered that part. Okay, and then multiply, subtract, and I've got a remainder of 7. That is going to be the remaining number of pints, right? Since I divided by 8. And there's 8 pints in a gallon, right? So I'm dividing by pints here. So I have 7 pints left over, right? Well, I can convert some of those pints into quarts, right? So we know that there are 2 pints in 1 quart, right? So if I've got 7 pints, draw you a visual here. pint, pint, pint. 1, 2, 3, 4, 5, 6. So I draw 7 pints. All right. So every 2 pints can make a quart. So here's a quart. Here's another quart. Here's another quart. So I can have 3 whole quarts there from the 7 pints that were left over, and then I have 1 pint left over that I can't convert to any either gallons or quarts. So then the answer there would be 39 pints can be used to make 4 whole gallons, 3 whole quarts, and then there would be 1 pint left over. So that problem is a little intricate. A lot of people make the mistake of thinking, well, the problem just wants me to convert 39 pints into gallons, and then 39 pints into quarts, and then 39 pints into pints. And that's not what it's asking. It's asking, like I said, that example of filling up containers till they're full. So how many whole gallons can I create, how many whole quarts I can create, and then how many pints are left over after that. So this is another one of those long division problems. Okay. Alright, so some subtraction problems. This is another one of those borrowing problems. Notice that I can subtract 3 gallons and 1 gallon, but I can't subtract 3 quarts from 0 quarts without getting a negative, and that really wouldn't make any sense because 3 gallons is larger than 1 gallon's 3 quarts, so it shouldn't be a negative answer. So we do the same thing. We essentially borrow. So I'm going to borrow a gallon from the 3 gallons and make 4 quarts with it, because 4 quarts is equivalent to 1 gallon. So 2 gallons and 4 quarts, that's the same as 3 gallons. That's equivalent. Now I can do my subtraction, right? Because I can subtract 1 gallon from 2 gallons and get a gallon, and then I can subtract 3 quarts from 4 quarts and get 1 quart, and then I would have 1 gallon and 1 quart left. Okay. This is a division. 5 gallons, 6 fluid ounces divided by 2. I would recommend figuring out how many fluid ounces this is total. All right, so we know that we're going from 5 gallons all the way to fluid ounces, so from gallons to quarts. To pints. To cups. To fluid ounces. So if I multiply all that out, 5 times 4 times, 5 times 4 times 2 times 2 times 8. I get 640 fluid ounces. Sorry, I was checking my answer there. Okay, so should be 128 fluid ounces in 1 gallon. So if we do 128 times 5, that should give us 640. So that works. Okay, so that's just for the 5 gallons plus, right? We've got 6 gallons there. So we've got, I'm sorry, 6 fluid ounces. So 640, that's in the 5 gallons plus the 6 fluid ounces. We end up getting 646 fluid ounces total. Okay, zoom out a little bit. And so that is nicer because that's one single number, right? You know, I could divide that by 2 pretty easily since it's even. So we get 323 fluid ounces. Okay. It doesn't specify what we should answer in, right? So I guess that would be left up to the MyMathLab. Okay. However, we know that there's 128 fluid ounces in 1 gallon. So we know that there's at least 2 gallons in here, right? Because 128 times 2 would be 256. And then if I subtract 256 from 323, that tells me that there would be 68 fluid ounces remaining. So if we want to convert it back to whole gallons and fluid ounces, basically just basically just do 128 times 2, because there's 128 fluid ounces in a gallon, and that gives me 256. So I know that there's at least 2 gallons, and basically I'm just trying to get as close to 323 as I can. If I did 3, I'd be over 323. So 2 times 128 gives me 256, and then 323 minus 256 gives me the remaining 67 fluid ounces. So okay. Alright, these next problems is our metric system here, so keep in mind we're using this last row. So we're going from 250 liters to kiloliters, so find the unit that you're starting with, which is here, liters. I want to go to kiloliters, so I'm going 1, 2, 3 places to the left. That's where I'm going to move that decimal. So my decimal in 250 is right here. If I move that 3 places to the left, puts it here, so that would be 0.250 kiloliters. So once again, metric system is really nice. Just move that decimal around. Okay, 1.7 liters to centiliters. So here's liters, here's centiliters. So I'm going to move the decimal 2 places to the right. So here's the decimal in 1.7, 1, 2, and then I'm going to put a 0 in between that wave. So 170 centiliters. And then 8 liters to milliliters. So I'm going from liters to milliliters. So I'm going to go 1, 2, 3 places to the right. So I'm going to move that decimal. So here's the decimal in 8. 3 places to the right. 1, 2, 3. So 8,000 milliliters. So if you're doing the metric system, just use the conversion sheet that I have given you to help you out. Alright, so here's some arithmetic problems. You've got liters, milliliters, answer in liters. So that means I want to convert this to liters because this is already in liters. So if I'm going from milliliters to liters, I'm going to move the decimal 1, 2, 3 places to the left. So then there's going to be 0.283 liters there. Oops, you can't see that. Okay. So then subtract those two, and you get 4.517 liters. Okay. This is adding. We're going the other direction. We want the answer in milliliters, so I'm going to take the liters and convert it to milliliters. This is already in milliliters, so if I'm going from liters to milliliters, I'm going to move the decimal 3 places to the right. So 1, 2, 3. Okay. So I'm going to take the decimal in liters here, move it 3 places to the right. 1, 2, 3. So that should be equal to 4,600 milliliters plus the 1,600 that we're adding it to should give us 6,200 milliliters. So once again, metric system is much easier than standard. That's why the rest of the world uses it. So, all right. If you have any questions, please email. Come by the office for office hours. Have a great day.